So next we are moving into three-dimensional coordinates, and we will study cylindrical and spherical coordinates. So let's start with cylindrical coordinates. So you all know that in 3 dimensions we can use 3 numbers, x, y, and z, to locate any point in space. But we can also use 3 alternative numbers called ρ, phi, and z. Okay, and these are the cylindrical coordinates, and they are defined in this way. Now, the best way to understand cylindrical coordinates is to just imagine that in the xy plane, which would be this plane here, so this is the xy plane, here we are using polar coordinates. So we have this distance here, which is ρ, and we have this angle here, which is phi. And that is exactly what we saw in the xy plane for polar coordinates, okay? So now that will give us x and y using ρ and phi. And notice that that equation is exactly this equation. So once we are located in the xy plane by using ρ and phi, then we can just give an additional number, which is z, which is basically the height at which we are. Okay? So let me show you an applet where I can vary the 3 coordinates, ρ, z, and phi. So here we have cylindrical coordinates applet, and this is how it looks like. So let's change some coordinates. For example, what happens if we change phi? So if you change phi, we are moving around the z-axis, right? Exactly like it happened in the polar coordinates. So we are in the xy plane, changing phi, the angle with the x-axis, in this xy plane. Now, if we change ρ, so ρ is equal to the distance, but be very careful. It's equal to the distance between the point and the z-axis, okay? It's this distance here, ρ. It's not the distance between the point and the origin. It's the distance between the point and the z-axis, which is the same as this distance on the bottom here, which corresponds to what I was showing in polar coordinates. So it's this distance within the xy plane, okay? So you can imagine that the z direction in this picture would be out of the plane, and ρ is ignoring the fact that we might move out of the plane. Okay, so ρ is defined in the xy plane. So that is ρ. So this means that if ρ goes to 0, we end up in the z-axis. So that's what happens when ρ goes to 0. If we increase ρ, we are just increasing the distance to the z-axis. Okay? So I have very clearly labeled ρ here, in this point here. And finally, the last slider of cylindrical bases is z. And z is simply a slider that allows us to move up and down in the z-axis. Okay? But notice that ρ is kept constant. So this distance here is kept constant. We are just moving up and down. Okay? So you see that even though the length of this red line is changing, ρ is not changing. Yeah, ρ, the Greek letter ρ, is not changing because it's the distance to the z-axis. Notice that when z equals 0, if I specify exactly z equals 0, now we are exactly on the xy plane, and then the only 2 variables that are not 0 are ρ and phi, and this has been transformed into polar coordinates, basically. Yeah. So now phi determines the angle, while ρ determines the distance to the z-axis. Okay? Okay, so that is cylindrical coordinates in summary. And when are cylindrical coordinates particularly useful? As the name suggests, they are particularly useful to describe a cylinder. Okay? So what is the equation of a cylinder in cylindrical coordinates? It's just saying ρ equals the radius of the cylinder. And that is the equation of a cylinder because the distance to the z-axis is this value of r, so that defines a cylinder. You can further specify the height of the cylinder by saying that z is a variable that moves between 0 and h, for example. So that will be a cylinder that starts at z equals 0 and goes up to z equals h. And that would define the cylinder. And then phi would be the angle going from 0 to 2 pi. And to see how this would indeed represent a cylinder, I can activate a cylinder here. So if you fix rho, which is the top slider here, now I change the other two sliders and I'm just moving along the surface of this cylinder. Yeah. So either by changing Z or by changing phi, I'm just moving along the surface of this cylinder. But I am always contained within the cylinder. The cylinder only changes if I decide to change the slider for rho. So if I change rho, this changes the radius of the cylinder. Okay? Excellent. Next, we can have a look at spherical coordinates. And now things are getting a bit more interesting. So in spherical coordinates, instead of having rho, phi, and z, we now have one distance and two angles. Okay? So we have r. To distinguish it from polar, I call it r. I no longer call it rho. Okay? So this is r, which is the distance to the origin. This time r is the distance to the origin. Okay? And then we have two angles, theta and phi. In order to understand what these angles are, we have to actually look at them. Okay? So here we can see the three numbers. We have r, which is this distance here, from the point to the origin. Then we have angle phi, which is the same angle as in polar coordinates and in cylindrical coordinates. Okay, that is angle phi, which is the angle in the xy plane with the x-axis. So you project your point into the xy plane, yeah, and the angle that this line makes with the x-axis, that is phi. But now we have an extra angle, which is this angle theta. And this angle theta is the angle between the z-axis and the line that joins the origin with the point. Okay, so this is the angle theta. The angle theta is sometimes called the polar angle because it's like the angle with the z-axis, which sometimes is called the polar axis. Okay, while the angle phi is sometimes called the azimuthal angle. Okay, so let me write it down. Azimuthal angle. Phi and polar angle theta. To add to the confusion, some textbooks change the symbols between theta and phi, unfortunately. Okay, but in this module I'm always going to use this same convention. So let's look at the applet to try to explain all these two angles and the distance r. So here I have the applet for spherical coordinates, and we see the same plot we were watching, but now we have the three sliders. Okay, so the three sliders are up here. So if we change r, this time we are changing the distance to the origin. So we are really changing the length of this red line. Okay, that's the change of r. If r goes to 0, we are going into the origin. Okay, good. Now if we change, let's start by changing phi. If we change phi, we already know what happens. We move around the z-axis. This is identical to what happened in polar coordinates and also what happened in cylindrical coordinates. So the angle phi is the same phi for the three cases. But now the angle theta is very interesting because the angle theta goes from theta equals 0, which means that we are in the z-axis, and then you can increase theta, and this moves the angle from the z-axis. Okay, think about what is the minimum and maximum value of the angle theta, because while the angle phi is 0 to 2 pi in order to go round in the xy plane, the angle theta is a bit different. So think about it. I can ask you that in the live session. Okay, so with this we can point to any point in space by using three numbers, r, theta, and phi. Also note that it is very easy to describe a sphere using spherical coordinates by fixing r equal to the radius. And then we fix a sphere, and then the two angles theta and phi just allow us to move throughout the sphere. Okay, this is actually very similar to how locations are specified on the surface of Earth using two angles, latitude and longitude. Okay, so this is clearly very related to the two angles in spherical coordinates. Okay. So to add here in the whiteboard the equation for a sphere in spherical coordinates, so that would simply be little r equals capital R, radius of the sphere. Okay, and then the other angles are phi going between 0 and 2 pi, and theta going between 0 and pi. If you thought about it, you realize that you can only increase theta up to pi. Okay? One last thing that I would like to mention is the actual equations for converting between the two systems, x, y, z and r, theta, phi. Okay? So these equations are very well known. Sometimes it's easy to forget, is it sine and cosine here? So is it theta and phi, or is it phi and theta? So it can be a bit tricky, but I want to calm you down because I will provide any of these equations in the exam, right? So if we go to Kits and we go to the reference list of equations here, indeed I provide a nice table where I give for different coordinate systems, I provide how to change the coordinates from one system into the other. Okay? So this is given. I also encourage you to think about these equations and try to think why they make sense from a geometrical point of view. It's just looking at right angle triangles and thinking a little bit about the projections. Okay? Excellent. So in the next video, I will give you some equations for surfaces that are not as simple as the equation for a sphere, so that you get used to working with cylindrical and spherical coordinates. Thank you very much.